So let's take a look at formal charges. So formal charges is going to tell you basically which Lewis structure is going to predominate over it. So let's take a look at this one. This is actually the thiocyanate ion, SCN negative. So I've drawn three possible Lewis structures for it, and I want to say which one is going to be the best one in a matter of speaking. So to do this, we're going to get formal charges. So let's look at structure one. Let's look for sulfur. To get the formal charge, it's the number of valence electrons. So sulfur has 6 valence electrons. Minus number of bonds. It's got one bond. Minus 1. Minus the number of electrons around it. So it's 2, 4, 6. Minus 6. So its formal charge for sulfur now is negative 1. Let's do it for carbon. So carbon has 4 valence electrons, group 4A. It's got 4 bonds, minus 4. That's 0. Let's do it for nitrogen. Nitrogen has 5 valence electrons, it's a group 5A. 3 bonds, and then 2 electrons around it. So that's going to be 0. Let's go ahead and do it for the second structure. So in this case, sulfur. So again, that 6 is not going to change for sulfur. It's a 6A. Minus 4 bonds, minus 4, negative 2. So 4 bonds. In fact, that's wrong. I'm sorry. It's 2 bonds. Sorry about that. So that's going to be 0. So again, that's 2 bonds and then 4 electrons. Let's do it for carbon. 4 minus 4 is 0. And then let's do it for nitrogen in this case. 5 minus 2 minus 4 is negative 1. So again, the total charges has to be negative 1 because it's a negative 1 right there. So negative 1, 0, 0, that's correct. Negative 1, 0, 0, that's correct. So thiocyanate, SCN negative, so its formal charges have to be equal to negative 1 overall. Let's go ahead. Let's do the third structure. So again, sulfur 6 minus 3 minus 2, positive 1. Let's do it for carbon. 4 minus 4, that's 0. And then nitrogen again, that's going to be 5 minus 1 minus 6 is minus 2. Again, that's going to add up to negative 1. So again, it always has to have a negative 1. In terms of deciding which structure is the best, you want to have the ones closest to 0, and then you want the negative to be on, preferably the more electronegative element. So this one right here, I have a positive 1, negative 2, so this one's not going to predominate. The other ones are a little bit closer to 0, 0 or closer. So 0 will be this one or this one. So I got 2 zeros and 1 negative. Now in this case, nitrogen is more electronegative than sulfur. So I want that negative to be on a nitrogen. So in this case, nitrogen, this is the one that has a negative charge on nitrogen. So this is actually going to be the Lewis structure that's going to predominate. Let's take a look at this one. This is carbon monoxide. I want to go ahead and draw the Lewis structure for it. It's a little bit unusual. So again, in this case, I have 10 electrons to work with. Some are going to be bonded, some are going to be non-bonded. The way to start off with was carbon and oxygen. Single bond between carbon and oxygen. They're both, it's linear, it's only 2 atoms, but always kind of think of carbon as the central one. I'm going to put 6 electrons around oxygen. So 1, 2, 3, 4, 5, 6. So I've used up 6 electrons plus 2 for the bond. So minus 6 minus 2. So I have 2 electrons left that have to go in carbon. And so I'm going to draw it like this. Couple things now when I'm looking at it. Let's count up how many valence electrons carbon has. So carbon now, it needs 8, but it only has 2, 4. Only has 4 electrons around it. The only way now for it to get 8 is really to make 2 more bonds between the oxygen and the carbon. So carbon is going to get a triple bond in this case right here. So I'm going to move these electrons here and these electrons right there. So actually I'm going to end up with something like this. So this is actually the Lewis structure of carbon monoxide. Let's go ahead and count the number of valence electrons each one. So carbon is going to have 2 plus 3 bonds and 6 electrons, so that's satisfied. And then oxygen, of course, is going to have 6 electrons. But let's take a look at the formal charges. Let's look at carbon. So carbon, the number of valence electrons is 4. 3 bonds plus 2 electrons. So its formal charge is -1. And then oxygen, 6 is the number of valence electrons, 3 bonds, -2, so +1. So that adds up to 0. So even though oxygen is more electronegative, it has a positive charge in terms of formal charges, and carbon has -1. So again, those rules don't always work perfectly for that.